So find the value of x for which this function is increasing, decreasing, concave up, concave down. So, and then we're going to sketch it. So something to think about, which I think we often forget, is don't forget we can use the actual function as well. And it's pretty easy to see that if I sub in x equals 0, I get y equals 0. So straight away, I know that 0, 0 is a point that lies on that graph. If it talks about sketching it, I'm going to look for obvious things, even if, because you know, if they don't kind of touch on what's obvious in the scaffolding of the question. Make sure you do think about what is obvious about this question. So there's a couple of points on there that are really obvious, like 0, 0, but probably 1 as well. 1 and minus 1 are pretty obvious on there as well, but let's just say we got 0, 0, that's nice. Okay, so you could just plot some points and you get a general idea of what's happening as well. But of course, increasing, decreasing, concave up, concave down. So increasing, decreasing, we're talking about y dash. So let's have a look at y dash. So when I differentiate, so 2/3 x to the take away 1 would be 1/3 there. Another way to write that would be 2 over 3 cube root of, oh, that's cube root of x. All right, what about y double dash? So then I'm putting minus 2 on 9, x to the minus 4/3. Another way of writing that would be negative 2 on 9, so the cube root of x to the power of 4. Is that right? Hopefully. All right. So if we know that, that kind of makes it easy. So first of all, we're looking for increasing and decreasing functions where it increases and decreases. So we're looking at double dash. Now you can see if I put positive values of x in there, then that is going to be positive. So we know when x is, I might just do it here. So when x is positive, I'll do negative. And when x is positive. All right, so we know that y dash when x is positive, so putting it in here, is positive. So it's increasing. Whoops, I just wrote that for the wrong one. Of course I did. So I was looking at this, wasn't I? So it is greater than 0, therefore increasing. So for positive values of x, it's increasing. What about for negative values of x? I'm finding the cube root, which will stay negative, of a negative. So 2/3 of that will be a negative. So y dash in this case, when x is negative, will be a negative. Therefore, it'll be decreasing. So think of the curves decreasing on the left-hand side. It's increasing on the right-hand side. All right, so now let's have a look at double dash. So I'll start at the positives again. So when I put a positive in there for x, it doesn't really matter. I've still got, because of this negative here, I've got a negative. So y double dash is going to be negative. What does that mean? It means concavity is like that. So it's part of a concave down cavity. Concave, it's hard to write here, down. What about my y double dash when I put x as negative in? So you can see here, because it's to the power of 4, it's going to make it positive. So it's not going to change any of this part, but we've still got this negative out the front. So again, it's going to be less than 0, so it's concave down. All right. So if you think about it, on the right-hand side of the graph, we're increasing and concave down. On the left-hand side of that y-axis, we're decreasing and we're concave down. Now that might seem hard, but and just go back to this and think about this. Another thing you can think about is if I put in negative x, I will get negative x. Now it's squared and cube rooted, right? That's what 2/3 means, squared and cube, or cube rooted and squared, doesn't matter what order. But if I square, I'm going to get a positive x squared, same thing. So it's the same as doing just f of x. Okay, what does that mean when f of negative x equals f of x, that means it's an even function. Now that makes it easier, really. Yes, using increasing, decreasing, concave up, concave down, they're really helpful tools, but don't forget all the other tools. So if I just look at the right-hand side of the y-axis, when x is positive, we know it has a point at 0, 0. We know it's part of a concave down curve, all right, and it's increasing. So concave down curve, and it's increasing. Now, if it's an even function, it should look exactly the same on the other side, which makes sense because remember it's decreasing. So if you take this point and then this point and then this, if you go down here, you'll see it is decreasing and it is concave down. So it's going to look something like that. All right, the other thing you could do, just use your tools again, is just sub in some points, easy points like we did 0, 0. What about 1? Well, 1 to the 2/3 is still 1, so say this was 1 over here. So this point here would still be 1, 1. What about -1? So if I put -1 in, remember I'm squaring and cube rooting, so I'm still going to get 1 there. All right. So really you can use other tools, not just the ones they say. As soon as they say sketch the graph, just think, oh, I've got to use all the tools I can use. All right.